solve some example related to the gravitational force that we studied last time. So the first example is there are two spheres of uniform densities. The masses of the two spheres are 10 kg and 40 kg. The distance between them is 200 meters. We have to find the gravitational force acting on each other, the gravitational force which is between them. So the first thing we will write down the data. So given data is the two masses first, m1 which is 10 kg and m2 which is 40 kg. The distance between the two masses is r is equal to 200 meters. So all the given data are in this SI form, no need of any conversion. We just put it in the formula G m1 m2 upon r squared, where the value of G is 6.67 into 10 raised to minus 11 Newton meter square per kg square. So we will substitute all the given data at a 6.67 into 10 raised to minus 11 multiplied by 10 into 40 divided by 200 the whole square. It will be 6.67 into 10 raised to minus 11 into 400 divided by 4 into 10 raised to minus 4. So the gravitational force acting on the bodies is 6.67 into 10 raised to minus 13 Newton, as Newton is the unit of measurement for force. So we can say that when there are two bodies of masses 10 kg and 40 kg and the distance between them is 200 meters, the gravitational force acting on both the bodies will be 6.67 into 10 raised to minus 13 Newton. So let's solve the second example. Here in the second example, we have to find the gravitational force acting on the man and the car. The mass of the man is 50 kg whereas the mass of the car is 1500 kg. The separation between them is 10 meters. So we have to find the gravitational force acting on them. So first we will note down the given data. So let's note down the given data. M1, which is the mass of the man, is 50 kgs. M2, which is the mass of the car, is 1500 kg, that is 1500 kgs. The distance or the separation between them is r, which is equal to 10 meters. The value of G, the constant value of G is 6.67 into 10 raised to minus 11 Newton meter square per kg square. We have to find the gravitational force acting on both the bodies. So we will write the formula first, m1 m2 upon r squared. Now substituting the values in the formula, G is 6.67 into 10 raised to minus 11 into m1 is 50 kgs whereas m2 is 1500 kgs. Divide by 10 the whole square, that is r the whole square. So the force is, after calculation we get the answer 5.0025 into 10 raised to minus 8 Newton. So the force acting on two bodies, that is a man and the car, when the car is 1500 kgs and the man is 50 kgs and the separation between them is 10 meters, the force acting on them is 5.0025 into 10 raised to minus 8 newtons. So now the third example. In this example, we have to find the gravitational force acting between the Sun and the Earth. So the mass of the Sun is given as 2 into 10 raised to 30 kgs, whereas the mass of the Earth is 6 into 10 raised to 24 kgs. The separation between the centers of both is 1.5 into 10 raised to 11 meters. So we have to find the gravitational force acting on both. So we will write the given data. M1, which is the mass of the Sun, is 2 into 10 raised to 30 kgs. M2, which is the mass of the Earth, is 6 into 10 raised to 24 kgs. Now the separation between them, or the distance between them, that is r, is 1.5 into 10 raised to 11 meters. We have to find the gravitational force, so we will write the formula first. F is equal to G m1 m2 upon r square. Here G is 6.67 into 10 raised to minus 11. M1 is 2 into 10 raised to 30 kgs. M2 is 6 into 10 raised to 24 kgs. R is 1.5 into 10 raised to 11 the whole square. So after calculations, after the multiplications and division, we get the answer 3.558 into 10 raised to 22 Newton. This is the answer. The gravitational force acting on the Sun and the Earth, which have the mass 2 into 10 raised to 30 kgs and 6 into 10 raised to 24 kgs respectively, and which are separated with a distance of 1.5 into 10 raised to 1.5 into 10 raised to 11 meters, the gravitational force will be 3.558 into 10 raised to 22 newtons.
A lot of students waste their precious time watching cartoons, movies, reality shows on TV. Then they waste their time on social networking sites. When the students sit to study, they are unable to concentrate to get your studies finished, and they get low marks in exams. Parents shell out tons of money from their pockets for coaching classes. But who knows what is taught in these classes? Teachers at times get bugged up when you ask them questions. YouTube has a lot of information but little of use. This is where Study Spectrum TV channel comes in picture. Every chapter explained by different teachers with different examples and repeat telecasts. We remember 20% of the audio ads we hear, 30% of the printed items we see. But we remember 70% of the audio visuals. That is why video teaching is a powerful medium to learn. After watching Study Spectrum TV channel, you get a peaceful sleep with no tensions and no worries. You devote less time towards your studies and you get better marks in your exams. Visit us on www.studyspectrum.com. Follow us on Facebook. So what are you waiting for? Subscribe for Study Spectrum TV channel and keep edifying.
Now the fourth example. In this example, this is a question where we have to find the magnitude of acceleration due to gravity on the surface of the Earth. So the mass, we will consider the mass of the Earth, and r, that is the radius. R is the distance between the two masses we always consider, but here r will be the radius of the Earth. So we will write down the given data, which has already been written. M is the 6 into 10 raised to 24 kg, which is mass of the Earth, and r is 6400 kilometer, which is the radius of the Earth. G, which is constant, the value of G is 6.67 into 10 raised to minus 11 Newton meter square per kg square. So we have to find the acceleration due to gravity, which is G equals to capital G m upon r square. Substituting the values, G is 6.67 into 10 raised to minus 11. Mass is the mass of the earth, which is 6 into 10 raised to 24. R is the radius of the earth, which is 6,400 kilometers. If we convert 6,400 kilometers into meters, it will be 6.4 into 10 raised to 6 meters. So substituting the value, 6.4 into 10 raised to 6 meters, the whole square. So the acceleration due to gravitation at the surface of the earth will be 9.77 meter per second square, and instead of 9.77 we rather take the value 9.8 meter per second square. So the acceleration due to gravity at the surface of the earth is 9.8 meter per second square. So the fifth question is, acceleration due to gravity on the surface of the earth is 9.8 meter per second square. What will be the acceleration due to gravity on the surface of other planet whose radius and mass is 2 times the radius of the earth? So first we will just write down what the statement means. It means the given data will be gravity, acceleration due to gravity of earth, that is GE, is 9.8 meter per second square, whereas the mass and radius of the other planet is 2 times the mass and radius of the earth. So we can write as the mass, that is m of other planet, is 2 times the mass of earth. So me is equal to half of mp. Similarly, the radius of other planet is 2 times the radius of earth. Now substituting the same values in the for the formula for gravitational force, we can write G is equal to Gm upon r square. This is for the earth, and for the other planet, Gp will be Gmp upon rp. If we take the ratio of both, that is Gp upon Ge, it will be Gmp upon Rp divided by Gme upon Re square. So G gets cancelled and it will be Mp upon Me into Re upon Rp the whole square. But as per the given data, MP is 2 times Me and Rp is 2 times Re. So substituting the values, MP is 2 times Me, so 2 upon 1 multiplied by, where Rp is 2 times Re, it will be 1 upon 2 the whole square. So this gets cancelled by 4 and the answer will be 1 upon 2. Now Gp is 1 upon 2 times Ge. We can write it as 9.8 divided by 2 and the answer will be 4.9 meter per second square. So if the mass and radius of any planet is 2 times the mass and radius of the earth, the gravitational force on the surface of that planet will be half the gravitational force of the earth, and it will be 4.9 meter per second square.
A lot of students waste their precious time watching cartoons, movies, reality shows on TV. Then they waste their time on social networking sites. When the students sit to study, they are unable to concentrate to get your studies finished, and they get low marks in exams. Parents shell out tons of money from their pockets for coaching classes. But who knows what is taught in these classes? Teachers at times get bugged up when you ask them questions. YouTube has a lot of information but little of use. This is where Study Spectrum TV channel comes in picture. Every chapter explained by different teachers with different examples and repeat telecasts. We remember 20% of the audio ads we hear, 30% of the printed items we see. But we remember 70% of the audio visuals. That is why video teaching is a powerful medium to learn. After watching Study Spectrum TV channel, you get a peaceful sleep with no tensions and no worries. You devote less time towards your studies and you get better marks in your exams. Visit us on www.studyspectrum.com. Follow us on Facebook. So what are you waiting for? Subscribe for Study Spectrum TV channel and keep edifying.
The weight of the body on the surface of the moon is 100 Newton. We have to find what is the mass of that body. So we will first write the given data, which is only the weight, that is W, is 100 Newton. Now weight is the gravitational acceleration due to gravity or the gravitational force acting on a body, acting on a particular mass. Using that relation between weight and mass, that is W is equal to mg, we can find out the value of m. So the gravitational force acting on the body on the surface of the moon is 1.63 meter per second square, or it is the acceleration due to gravity produced on the surface of the moon. So substituting the values, first we will simplify. M is equal to W upon G. So M will be equal to 100 divided by 1.63 meter per second square. So the mass of the body on the surface of the moon will be 61.35 kg. So we can say that if the weight of a body on the surface of the moon is 100 Newton, the acceleration due to gravity on that body will be 1.63 meter per second square, and hence we can say that the mass of the body, using the relation W is equal to mg, we can find out the mass of the body is 61.35 kg. Now the next example, we have a 100 kg bag which is placed on a wooden plank. We have to find the weight of that bag. The mass is 100 kg, we have to find the weight, and we also have to find the reaction of the wooden plank on the bag. So first we will write weight is equal to mg. Mass is given. We know that the acceleration due to gravitation acting on any body on the surface of the earth is 9.8. So weight of the bag will be 100 into 9.8, that will be W is equal to 980 Newton. So the weight of the bag will be 980 Newtons on the surface of the earth. Now if the bag is kept on a wooden plank, an equal and opposite reaction will be given by the wooden plank to the bag. That means an equal amount of force, that is 980 Newtons of force, will be exerted by the wooden plank on the mass of the wheat bag. So the weight of the bag is 980 Newtons, and an equal amount, that is 980 Newtons, will be applied by the wooden plank on the wheat bag, which is the force of reaction.